Langchain Google Vertex Vision Models Vertex Image Editor Chat. Vertex AI Image Editor Chat is a conversational AI service for image editing. It enables users to edit images by providing natural language instructions. Inputs: a uniform resource locator URL pointing to the image to be edited. This URL could be from a website, a cloud storage service, or a local file system, provided it is accessible to the AI service. For example, the user might input the URL of a photo stored on their Google Drive. A textual description of the desired image edits. This prompt should be clear, concise, and specific. For instance, the user might provide a prompt like "make the sky bluer" or "add a hat to the person in the image." Outputs: an edited image that reflects the changes requested in the text prompt. The edited image is returned in a format compatible with the input image format. For example, if the original image was a JPEG, the output image will also be a JPEG. Steps: the image identified by the provided URL is uploaded to the Vertex AI service. This ensures that the service has access to the image data for processing. The user's text prompt is sent to the service. This prompt is interpreted by the AI model to understand the desired edits. The image is processed by the AI model based on the user's text prompt. The model applies image editing techniques, such as color correction, object detection, or image generation, to modify the image as instructed. The edited image is downloaded from the Vertex AI service and returned to the user. This final image is the result of the IS processing and reflects the requested edits. Prerequisites: a Google Cloud project is required to use Vertex AI services. This project serves as a container for all resources, including the AI models and data used in the project. Users can create a new project or utilize an existing one. A project ID is associated with each Google Cloud project and acts as a unique identifier. The Vertex AI Application Programming Interface API needs to be enabled for the project. This API provides access to the various Vertex AI services, including Image Editor Chat. Enabling the API grants the project the necessary permissions to interact with the AI services. Fine-tune parameters. Model fine-tuning involves customizing the underlying AI model's parameters to enhance its performance on specific types of image editing tasks. This process involves training the model on a dataset of images and corresponding edits, tailored to the desired editing style or domain. Image editing prompt engineering refers to crafting effective text prompts that guide the AI model to perform the desired image edits. This requires understanding the model's capabilities and limitations, using clear and unambiguous language, and providing context for the requested edits. For instance, instead of simply saying "make it brighter," a more effective prompt might be "increase the brightness of the image by 20. Challenges and fixes. Image size and format can significantly impact the processing time and efficiency of the AI service. Large images may take longer to process, potentially causing delays in the editing process. Different image formats may also have varying levels of compatibility with the AI model. Resizing images to an optimal size and converting them to a supported format can improve performance and ensure seamless integration. Ambiguity in the text prompt can lead to unexpected results. A prompt like "make it more colorful" might be interpreted differently by the AI model depending on the context. Clarifying the prompt by providing specific details, such as which areas to focus on or what colors to use, can eliminate ambiguity and ensure accurate edits. Unrealistic image editing requests can be challenging for the AI model to handle. For example, adding an entirely new object into an image or drastically altering its composition might be beyond the model's capabilities. It's important to limit editing requests to plausible modifications, ensuring that the edits are achievable and maintain the integrity of the original image. Computational resources, such as processing power and memory, are essential for the AI model to efficiently handle image editing tasks. Large images and complex edits require significant computational power. Optimizing the AI model for efficiency and using efficient image processing techniques can reduce computational demands and improve performance. Ethical considerations are crucial in image editing, particularly with AI-powered tools. Ensuring responsible image editing involves being mindful of potential biases, avoiding misrepresentation, and respecting the privacy and intellectual property of individuals depicted in the images. The model should be designed and trained to minimize potential ethical risks and promote responsible use of the technology. Langchain nvidia AI endpoints callbacks. Callback functions are essential for monitoring and controlling the interactions between langchain, a powerful framework for building applications with large language models, and nvidia AI endpoints, high-performance cloud-based inference services for AI models. These callbacks provide insights into the execution process and allow for real-time adjustments. Inputs. A langchain model, which represents a large language model LLM like GPT-3 or BERT, capable of generating text, translating languages, writing different kinds of creative content, and answering your questions in an informative way. An NVIDIA AI endpoint, a remote service hosted by NVIDIA that provides access to powerful AI models for tasks such as image classification, object detection, or natural language processing. This endpoint allows developers to leverage these models without having to manage the infrastructure required to run them locally. Outputs. The output generated by the langchain model, which could be a text response, a translation, a creative text piece, or an answer to a question. The output from the NVIDIA AI endpoint, which depends on the specific AI model being used. This could be a classification label, a detected object, or a processed text. Steps. Initialize the langchain model, loading its parameters and configuring it for the task at hand. This ensures the model is ready to receive and process input. Send a request to the NVIDIA AI endpoint, specifying the desired AI model and providing the input data to be processed. This triggers the execution of the AI model on the endpoint servers. Process the response received from the NVIDIA AI endpoint, which contains the results of the AI model's processing. This step might involve interpreting the output, converting it to a desired format, or integrating it with other parts of the application. Prerequisites. NVIDIA AI endpoint credentials, required for authentication and authorization to access the NVIDIA AI endpoint. Application Programming Interface Key, a unique security token that identifies the application or user attempting to access the endpoint. Endpoint URL, the web address of the NVIDIA AI endpoint, providing the location where the AI model is hosted and can be accessed. Langchain model configuration, defining the settings and parameters for the langchain model to be used. Model name, the specific name or identifier of the chosen langchain model, specifying which LLM will be used for the task. Model parameters, the settings and values that control the model's behavior and output, allowing for fine-tuning of its performance and output quality. Fine-tune parameters. Callback frequency, How often the callbacks are executed during the interaction with the nvidia AI endpoint, enabling monitoring and control at desired intervals. Callback details. The specific information provided by the callback functions, offering detailed insights into the progress of the interaction, such as the current step, the input data, and any intermediate results. Challenges and fixes. nvidia AI endpoint unreachable. A situation where the endpoint is unavailable, possibly due to network issues, server downtime, or incorrect credentials. Verify endpoint URL credentials, ensuring that the provided URL correctly identifies the endpoint and that the API key used is valid and has the necessary permissions to access the endpoint. Langchain model error. An issue arising from problems with the langchain model, such as incorrect configuration, missing dependencies, or unexpected input data. Check model configuration parameters, ensuring that the model name, parameters, and dependencies are set correctly and that the input data is compatible with the models. Requirements. Callback execution issues. Problems encountered during the execution of the callback functions, potentially due to conflicts with other processes or limitations in the execution environment. Adjust callback frequency details. Modifying the frequency and details of the callbacks to resolve any conflicts or adapt to the specific needs of the application. Langchain Mistral chat models. Chat Mistral AI summarization. Chat Mistral AI is a wrapper for the Mistral AI chat model. This wrapper facilitates the interaction with the Mistral AI model, providing a user-friendly interface for utilizing its capabilities. Inputs. Text to be sent to the chat model. This input parameter represents the text that is provided to the chat model for processing. It could be a question, a statement, or any other textual input that the model needs to understand and respond to. For example, the input text could be a question like "What is the capital of France?" or a statement like "The sun is shining brightly today." Name of the Mistral AI model. To use this input parameter specifies which Mistral AI model should be used for processing the input text. Mistral AI offers a variety of models, each with its own strengths and weaknesses. Choosing the right model is crucial for obtaining accurate and relevant responses. For instance, if you are interested in summarizing a lengthy text, you might choose a model specifically designed for summarization tasks. Outputs. Generated text response from the model. The output of the Chat Mistral AI wrapper is the generated text response produced by the Mistral AI model. This response represents the model's interpretation and understanding of the input text. It could be a direct answer to a question, a summary of a text, a creative piece of writing, or any other form of text that the model generates based on the input. Steps. Initialization of the Mistral AI client. This step involves establishing a connection with the Mistral AI service. This connection allows the Chat Mistral AI wrapper to send requests to the Mistral AI models and receive responses. The initialization process typically involves providing authentication credentials, such as an API key, sending the input text to the chat model after establishing the connection with the Mistral AI service. The Chat Mistral AI wrapper sends the input text to the selected model for processing. The model then analyzes the input text and generates an appropriate response based on its training data and internal algorithms. Reception of the output response. Once the Mistral AI model has processed the input text, it generates a text response. The Chat Mistral AI wrapper then receives this response from the model and delivers it to the user. Prerequisites. Mistral AI Application Programming Interface Key. This prerequisite refers to an API key that grants access to the Mistral AI service. API keys are typically used for authentication purposes, allowing users to identify themselves and access specific features or resources provided by the service. For example, you might need an API key to interact with the Mistral AI models, send requests, and receive responses. Example values for prerequisite 1. These example values represent the actual API keys that can be obtained from the Mistral AI service. They are typically long strings of characters and digits, unique to each user. Mistral AI model name. This prerequisite refers to the name of the specific Mistral AI model that you want to use for your task. Mistral AI offers a variety of models, each with its own capabilities and limitations. You need to know the name of the desired model in order to select it and use it for processing your input text. For example, you might choose a model specifically designed for summarization tasks if you want to summarize a lengthy document. Example values for prerequisite 2. These example values represent the actual names of the Mistral AI models. They are typically short and descriptive, such as summarization model or chat model. Fine-tune parameters. Temperature. This parameter controls the randomness or creativity of the generated text response. A higher temperature value generally leads to more diverse and surprising outputs, while a lower value produces more predictable and coherent responses. Top P. This parameter determines the probability distribution of the words that the model considers when generating text. A lower top P value restricts the model's choices to only the most likely words, resulting in more conservative outputs. A higher value allows the model to consider a wider range of words, potentially leading to more creative and less predictable responses. Challenges and fixes. Incorrect application programming interface key. This challenge arises when an incorrect or invalid API key is used to access the Mistral AI service. This can prevent the chat Mistral AI wrapper from successfully connecting and interacting with the model. Fixes to challenge 1. To fix this issue, you need to ensure that you are using the correct API key provided by Mistral AI. This might involve checking the API key for accuracy, verifying that it is still valid, or requesting a new API key if the previous one has expired or become invalid. Invalid model name. This challenge occurs when the specified model name is incorrect or does not correspond to a valid Mistral AI model. This can prevent the chat Mistral AI wrapper from selecting the intended model for processing the input text. Fixes to challenge 2. To resolve this challenge, you need to verify the name of the desired Mistral AI model. Ensure that you are using the correct spelling and case sensitivity. If the model name is still invalid, you might need to consult the Mistral AI documentation or contact support to identify the correct model name. Langchain nvidia AI endpoints callbacks. Langchain nvidia AI endpoints callbacks are a valuable tool for enhancing the monitoring and management of interactions between langchain applications and nvidia AI endpoints. These callbacks provide a systematic approach to keep track of every stage of the communication process. Inputs. This refers to the data that is sent from a langchain application to an nvidia AI endpoint. It could include things like prompts, user input, or specific data structures needed for processing by the endpoint. For instance, if a user wants to generate text, their input would be the prompt they enter. This refers to the output generated by the nvidia AI endpoint in response to the langchain request. It could be any type of data processed by the endpoint, such as text, images, audio, or structured data. Imagine a chatbot responding to a user's query with a relevant answer. Outputs. This represents the data collected and processed by the callbacks. It can be a summary of the request-response interaction, any relevant metrics, or any other custom data you choose to track. A simple example might be recording the time it took for the endpoint to process a request. Steps. This phase involves setting up the callback mechanism. It includes registering callbacks, defining callback parameters, and configuring the communication channels. Think of it as prepping your recording equipment for the show. This stage entails receiving the langchain request, processing it into a format suitable for the nvidia AI endpoint, and then sending the request to the endpoint. In our chatbot scenario, this would involve translating a user's input into a format the chatbot understands. This involves receiving the response from the nvidia AI endpoint, potentially parsing or transforming it, and then storing or delivering the response to the appropriate langchain component. This is analogous to the chatbot processing the user's input and forming a response. This is the final step where the callback function is executed. It receives relevant information about the request-response exchange and performs the desired actions. This could involve logging data, triggering alerts, or updating the application state based on the interaction. This is similar to the chatbot actually sending its response back to the user. Prerequisites. This means that you must have the langchain library installed. Langchain is a Python library that simplifies interactions with various language models and AI services. Install it using the following command. This command uses pip, the package installer for Python, to download and install the langchain package from the Python package index pypi. This refers to the need for the NVIDIA AI Endpoint SDK. This SDK provides tools and libraries to interact with NVIDIA AI endpoints and integrate them into your applications. Install it using the following command. This command uses pip, similar to the langchain installation, to download and install the NVIDIA AI endpoint package from the Python package index pypi. Fine-tune parameters. This refers to the specific type of callback function you want to use. For example, you might choose a callback that logs all request-response interactions, or another type that triggers an alert only when certain conditions are met. This determines how frequently you want the callbacks to be executed. This could be after each request, after a batch of requests, or at specific intervals. Imagine setting the callback to run every 10 minutes to check the health of the system. This determines the format of the data recorded and processed by the callbacks. For example, you might choose to log the data in JSON format, a CSV file, or a database. It's like choosing the format in which you want to record your observations. Challenges and fixes. This refers to situations where the callback function fails to execute due to issues like network connectivity problems or errors in the callback code itself. It's like your recorder malfunctioning and missing some crucial parts of the performance. This step focuses on verifying the network connection between your langchain application, the NVIDIA AI endpoint, and any external services involved in the callback process. This involves checking for network connectivity issues, verifying firewall settings, and potentially restarting network components. It's like ensuring your network cables are plugged in correctly and the internet is working. This situation occurs when the data recorded by the callbacks is incorrect or inconsistent with the actual request-response interactions. It's like noticing discrepancies between your notes and what actually happened during the performance. This step involves reviewing the callback configuration and code to identify any errors in the data recording process. It's like double-checking your notes to make sure they accurately reflect what happened. This issue arises when the callbacks introduce significant performance overhead to the langchain application or the nvidia AI endpoint. It's like having a camera crew that's so big it slows down the performance. This step involves optimizing the callback logic and implementation to minimize the performance impact. It could involve reducing the amount of data collected, using efficient data storage methods, or leveraging asynchronous processing techniques. It's like streamlining the camera crew to reduce disruptions to the performance. Langchain nvidia AI endpoints callbacks get usage callback summarization. Provides an interface to monitor and track application programming interface usage and pricing for nvidia AI endpoints. This interface helps users understand their costs associated with using nvidia AI endpoints by providing insights into their API consumption. Inputs. nvidia AI endpoint client instance. This refers to the object or library that allows you to interact with the nvidia AI endpoint service. It typically provides methods for making requests to the nvidia AI endpoint API. Outputs. Usage statistics in desired format. This refers to the output provided by the callback function. It represents data about your API usage in a structured format. The format can be customized to include specific metrics or display information in a user-friendly way. Steps. Initialize the callback function. This step involves setting up the callback function itself. It defines the code that will be executed whenever certain events related to API usage occur. The callback function will typically gather usage data and potentially trigger actions based on that data. Connect to nvidia AI endpoint API. This step involves establishing a connection to the nvidia AI endpoint service. The callback function needs to interact with the API to retrieve usage data and perform other operations. Retrieve the endpoint ID and other relevant information. The callback function needs to identify a specific nvidia AI endpoint that you are monitoring. This often involves obtaining the endpoint ID, which is a unique identifier for the endpoint. Additional information may be required depending on the monitoring requirements. Query the API for usage statistics. Once connected to the API, the callback function sends queries to the API to retrieve data related to API usage. This data might include information about the number of API calls made, the time spent executing calls, and the amount of data processed. Process the data and format it is required. The retrieved usage data needs to be processed in formatted into the desired output format. This might involve calculations, aggregation, and presentation in a user-friendly way. Return the usage statistics. The final step involves returning the processed usage statistics in the specified format. This data can be used for various purposes, such as monitoring, reporting, or billing. Prerequisites. nvidia AI endpoint account. To use nvidia AI endpoints, you need to have an account on the nvidia AI endpoint platform. This account provides you with access to the service and allows you to create and manage endpoints. Valid API key. You need a valid API key to authenticate with the nvidia AI endpoint API. This API key is specific to your account and allows you to access the API and manage your endpoints. Langchain library installation. Langchain is a powerful library that simplifies the development of applications involving large language models. The callback function utilizes langchain for specific functionalities, and you need to have the library installed in your environment. Langchain version 0.0.212 or later. Make sure you are using a version of langchain that is compatible with the nvidia AI endpoint service. Fine-tune parameters. Interval for usage statistics updates. You can specify the frequency at which the callback function retrieves and reports usage statistics. This could be hourly, daily, or at any other interval that suits your needs. Desired output format. You can define the format in which the usage statistics are presented. This could be a simple text output, a table, a JSON object, or any other format that aligns with your requirements. Specific metrics to track. You can select the specific metrics you want to monitor. For example, you might only want to track the number of API calls or the total amount of data processed. Or you might want to track all metrics available. Challenges and fixes. API key authentication errors. If you encounter errors related to API key authentication, you need to verify that the API key is valid and has the necessary permissions to access the nvidia AI endpoint API. Make sure that the API key is correctly configured in your code. Verify the API key and permissions. Check the API key you are using and ensure that it is valid and that it has the required permissions to access the API. If you are unsure about the permissions associated with your API key, refer to the documentation provided by nvidia AI endpoints. Endpoint ID not found. If the callback function cannot find the endpoint ID you specified, it might indicate that the endpoint doesn't exist. Check the endpoint ID and make sure that it is correct. Check the endpoint ID and verify the endpoint exists. Review the endpoint ID you are using to ensure that it accurately corresponds to the endpoint you want to monitor. You can also check with the nvidia AI endpoint documentation or interface to confirm that the endpoint exists and is accessible. Invalid API response. If you receive an invalid response from the API, it could be due to incorrect request formatting or issues with the API itself. Check the API documentation and ensure correct request format. Consult the API documentation for nvidia AI endpoints to understand the correct format for requests. Pay attention to the parameters, headers, and other requirements. Data processing errors. If you encounter errors during data processing, it could be due to issues with data types, data structures, or the logic of your data processing code. Debug the data processing logic and ensure correct data types and structures. Thoroughly inspect your data processing code to identify any potential errors. Check that the data types and structures are consistent with what is expected by the API and your application. Rate limiting. NVIDIA AI endpoints might have rate limits in place to prevent excessive usage of their services. If you exceed the rate limits, you may encounter errors. Respect the API rate limits and implement retry mechanisms. Be aware of the rate limits imposed by the NVIDIA AI endpoint API and make sure your code does not exceed those limits. Consider implementing retry mechanisms to handle cases where requests are rejected due to rate limiting. This could involve waiting for a certain period before retrying the request. Langchain NVIDIA AI endpoints chat models summary. None. A langchain integration for NVIDIA AI endpoints. Use NVIDIA AI endpoints to run large language models (LLMs) in a production setting. This integration enables you to use langchain to easily access and interact with your deployed LLMs, making it simple to build powerful AI applications in a production environment. Inputs. A list of inputs to feed to the LLM. This input list could consist of text prompts, structured data, or a combination of both. The inputs are fed to the LLM for processing. Outputs. The output of the LLM. This output is the result of the LLM's processing of the input. It can be text, structured data, or a combination of both. Steps. Create an NVIDIA AI endpoint. This involves setting up the infrastructure for hosting your LLM and ensuring the necessary resources are allocated. Deploy your LLM to the endpoint. This involves uploading your trained LLM model to the endpoint so that it can be accessed and used. For inference, use langchain to interact with the endpoint. This involves using langchain's built-in capabilities to connect to the endpoint. Send inputs to the LLM and retrieve the outputs. Prerequisites. NVIDIA AI Endpoint. This is a cloud service provided by NVIDIA that allows you to deploy and run LLMs in a production setting. It offers various features like scalability, security, and high performance, making it suitable for real-world applications. Example values for prerequisite 1. For example, if you are using the NVIDIA AI endpoint, you might need to set up a secure connection to the endpoint using your credentials or API keys. You also need to configure the endpoint settings, such as the resource allocation and the LLM model you want to deploy. LangChain. This is an open-source Python library that simplifies interaction with LLMs. It provides a modular and flexible framework for building and deploying LLMs in various scenarios. It offers tools for integrating LLMs with other systems, managing the input-output, and using chains of LLMs to perform complex tasks. Example values for prerequisite 2. The specific prerequisites for using LangChain might depend on the version and the desired functionality. This might include installing the necessary libraries, configuring the environment variables, and understanding the basics of Python programming. Fine-tune parameters. Fine-tune the LLM using your own data. This involves using your specific data to train the LLM, allowing it to perform better on tasks related to your domain. This customization helps the LLM adapt to your specific needs and generate more relevant and accurate outputs. Challenges and fixes. Latency and performance issues in production settings. You might encounter delays in the processing time or reduced performance. This can be due to factors like network congestion, hardware limitations, or inefficient code execution. Optimize the endpoint configuration for maximum performance. This involves choosing the appropriate hardware, optimizing the code, and adjusting the endpoint settings to reduce latency and improve throughput. This might involve using faster processors, increasing the allocated resources, or using caching mechanisms to reduce the number of computations. Security considerations when deploying LLMs in production settings. You need to consider security vulnerabilities and implement appropriate safeguards. Implement appropriate security measures. This involves using secure connections, authentication protocols, and access control mechanisms to prevent unauthorized access to your LLM and the data it handles. This might involve using HTTPS, setting up authentication using API keys, and using firewalls to restrict access to the endpoint. LangChain NVIDIA AI Endpoints Chat Models. Chat NVIDIA Summary. NVIDIA AI Endpoints Chat Model is a powerful tool for integrating NVIDIA AI models with your applications. It provides a user-friendly interface for sending prompts and receiving responses from NVIDIA's pre-trained language models. You can use it to perform various NLP tasks such as text generation, translation, summarization, and question answering. Inputs. The input to this model is a text prompt. The text prompt can be any natural language text that you want to use as input for the NVIDIA AI model. For example, you can provide a question, a statement, or a description of a task that you want the model to perform. Outputs. The output of this model is a text response generated by the NVIDIA AI model. The text response is a natural language text that is relevant to the input text prompt. For example, if you provide a question as input, the model will generate an answer to the question. If you provide a description of a task, the model will generate a text that describes how to perform the task. Steps. Send prompt to NVIDIA AI endpoint. This step involves sending the text prompt to the NVIDIA AI endpoint. The NVIDIA AI endpoint is a web service that allows you to interact with NVIDIA's pre-trained language models. You can use the NVIDIA AI endpoint to send prompts, receive responses, and manage your NVIDIA AI models. Receive response from NVIDIA AI endpoint once the text prompt is sent to the NVIDIA AI endpoint. The NVIDIA AI model processes the prompt and generates a text response. This text response is then sent back to you, completing the process. Prerequisites. NVIDIA AI endpoint account. You need an NVIDIA AI endpoint account to access and utilize NVIDIA's pre-trained language models. You can create an NVIDIA AI endpoint account by signing up on the NVIDIA AI endpoint website. Application Programming Interface Key. This is a unique identifier that is used to authenticate your requests to the NVIDIA AI endpoint. You can obtain your application programming interface key from your NVIDIA AI endpoint account settings. NVIDIA AI endpoint deployed model. You need to deploy an NVIDIA AI model to the NVIDIA AI endpoint before you can use it. NVIDIA provides a variety of pre-trained language models that you can deploy to the NVIDIA AI endpoint. The model deployment process involves selecting a model, configuring its settings, and then deploying it to the NVIDIA AI endpoint. Model name. This is the name of the NVIDIA AI model that you have deployed to the NVIDIA AI endpoint. You will need to specify the model name when sending requests to the NVIDIA AI endpoint. For example, you might deploy a model called GPT-3 to the NVIDIA AI endpoint. You would then use the model name GPT-3 when sending requests to the NVIDIA AI endpoint. Fine-tune parameters. Temperature. This parameter controls the randomness of the generated text response. A higher temperature value will result in more random responses, while a lower temperature value will result in more predictable responses. You can adjust the temperature value to fine-tune the creativity and predictability of the models. Responses. Top P. This parameter controls the diversity of the generated text response. A higher top P value will result in more diverse responses, while a lower top P value will result in more focused responses. You can adjust the top P value to control the range of topics and ideas that the model explores in its responses. Challenges and fixes. Rate limiting issues. The NVIDIA AI endpoint may impose rate limits on the number of requests that you can send in a given time period. If you exceed the rate limit, you may encounter errors or delays in your requests. Increase rate limit. You can try increasing the rate limit by contacting NVIDIA AI endpoint support or upgrading your account. Model unavailable. The NVIDIA AI model may be unavailable due to maintenance or other issues. If the model is unavailable, you may encounter errors when sending requests to the NVIDIA AI endpoint. Retry request. You can try retrying your request later. Check model status. You can check the status of the NVIDIA AI model on the NVIDIA AI endpoint website to see if it is available. Langchain. NVIDIA AI endpoint's callbacks. Get usage callback summary. This callback tracks the usage of NVIDIA AI endpoints when using langchain. This is useful for monitoring and understanding the resource consumption associated with the AI models deployed on nvidia AI endpoints. Inputs. A langchain model instance is required as input. This represents the specific AI model you are using for your tasks. For example, a large language model or a specialized machine learning model. The NVIDIA AI endpoint configuration is essential for establishing communication with the endpoint. This configuration will typically include details like the endpoint URL and any required authentication credentials such as an application programming interface key. Outputs. The callback generates usage statistics for NVIDIA AI endpoints. This data can include metrics such as the number of requests made to the endpoint, the amount of data processed, and the time taken for each request. Steps. The first step involves initializing the langchain model instance. This sets up the chosen model and prepares it for interacting with the NVIDIA AI endpoint. The next step establishes a connection to the NVIDIA AI endpoint. This is done using the provided configuration, including the endpoint URL and authentication credentials. Once the connection is established, requests are executed against the NVIDIA AI endpoint. These requests are based on the tasks you are performing with the langchain model. The final step involves collecting the usage statistics from the NVIDIA AI endpoint. This data is gathered as a result of the requests made to the endpoint and provides insights into the model's usage patterns. Prerequisites. Langchain, a powerful Python framework for building and deploying AI applications, needs to be installed. You can install langchain using the following command: pip install langchain, NVIDIA AI endpoints. A service for deploying and running AI models needs to be configured. This involves setting up the endpoint, including specifying the AI model you wish to use, and configuring any necessary access permissions. Fine-tune parameters. An application programming interface key is required for accessing NVIDIA AI endpoints. This key acts as a secure authentication credential, allowing your application to interact with the endpoint. The NVIDIA AI endpoint URL is crucial for establishing communication with the endpoint. This URL serves as the address for your application to connect to the specific endpoint hosting AI model you wish to use. Challenges and fixes. Authorization errors can occur if the application programming interface key is incorrect or if the endpoint URL is not valid. Ensure you are using the correct key and URL when connecting to the endpoint. Connection issues can arise if there are network connectivity problems between your application and the NVIDIA AI endpoint. Check your network connection to ensure a stable and reliable link to the endpoint. Langchain NVIDIA AI endpoints embeddings NVIDIA embeddings summary. This YAML document provides a comprehensive summary of the NVIDIA embeddings service, which leverages NVIDIA's cutting-edge AI models to generate text embeddings. Embeddings are numerical representations of text, allowing AI systems to understand the meaning and relationships between words and phrases. Inputs. Text. This represents the textual input that the NVIDIA embeddings service will process. For example, you could provide a sentence, paragraph, or even an entire document. Outputs. Embedding is a list of floats. The output of the NVIDIA embeddings service is a numerical representation of the input text, encoded as a list of floating point numbers. This embedding captures the semantic meaning of the text and can be used for tasks like similarity search, text classification, and recommendation systems. Steps. Send text to NVIDIA model. The first step in the process involves transmitting the input text to the NVIDIA AI model. This model is responsible for understanding the meaning of the text and generating a numerical representation of it. Receive embedding from model after processing the input text. The NVIDIA AI model returns an embedding, which is a list of floating point numbers that captures the semantic meaning of the text. Prerequisites: NVIDIA AI endpoint. To utilize the NVIDIA embeddings service, you need access to an NVIDIA AI endpoint. This endpoint serves as a communication channel between your application and the NVIDIA AI models. You can obtain an NVIDIA AI endpoint from NVIDIA directly. Application Programming Interface Key for NVIDIA AI endpoint. To authenticate your requests to the NVIDIA AI endpoint, you require an API key. This key provides secure access to the NVIDIA AI models and ensures that your requests are authorized. You can also obtain an API key from NVIDIA. Fine-tune parameters. Non-NVIDIA embeddings does not currently support fine-tuning. This means that you cannot customize the models or tailor them to your specific needs. However, NVIDIA continues to develop and improve its AI models, so future versions may offer fine-tuning capabilities. Challenges and fixes. Connection issues. If you encounter connection issues when interacting with the NVIDIA embeddings service, you should first verify that your API key is correct and that the endpoint URL is properly configured. Rate limiting. NVIDIA embeddings may impose rate limits to prevent abuse and ensure fair resource allocation. If you exceed these limits, you might experience delays or errors. To address this, you can reduce the number of requests you send to the service or utilize batching techniques to process multiple requests simultaneously. Model availability. NVIDIA's AI models may be temporarily unavailable due to maintenance or other reasons. To stay informed about model availability and potential issues, you can check NVIDIA's status page for updates. Application Programming Interface changes. The NVIDIA Embeddings Services application programming interface API may evolve over time, leading to changes in the request formats or response structures. To avoid compatibility problems, it's essential to update your code to reflect the latest API specifications. Langchain Mitralai chat models. A completion with retry summarization. A langchain tool that sends requests to Mistral is chat models and retries if the request fails. Inputs. A string containing the text prompt for the Mistral AI chat model. For example, summarize the plot of the movie The Matrix. A string containing the name of the Mistral AI chat model to be used for the request, for example, Mistral 7B or Mistral 13B. Outputs. A string containing the response generated by the Mistral AI chat model. Steps. Establish a connection to the Mistral AI service by initializing the Mistral AI client library with the required credentials. Send a request to the chosen Mistral AI chat model with the provided prompt. This includes sending the prompt and any other required parameters. If an error occurs during the request, such as a timeout or a network issue, implement a retry mechanism. This involves defining the number of retry attempts and the delay between each attempt. The retry logic can be configured to handle specific error types and ensure that the request is sent successfully. Prerequisites. A unique key provided by Mistral AI for accessing its application programming interface API. This key is required for authenticating requests and ensuring secure communication with the Mistral AI service. This API key can be obtained from the Mistral AI account portal, where users can manage their API keys and access permissions. A software library designed specifically for interacting with the Mistral AI API. This library provides functions and methods for making requests, managing responses, and handling common errors. The Mitrali library is a popular choice for interacting with the Mistral AI API. Fine-tune parameters. The number of times the request will be resent if an error occurs. The amount of time in seconds to wait before retrying a failed request. Challenges and fixes. The request may take too long to complete, leading to a timeout error. Increase the maximum time allowed for the request to complete. This can be achieved by adjusting the timeout setting in the Mistral AI client library. The Mistral AI API may impose rate limits on the number of requests that can be made within a certain time period. Implement a back-off strategy to avoid exceeding the rate limits. This involves introducing delays between requests, gradually increasing the delay if errors occur due to rate limiting. This allows the system to recover and reduce the impact of rate limiting. Langchain nvidia AI endpoints image gen nvidia. This YAML represents a langchain component that utilizes nvidia AI endpoints to generate images. It outlines the process, inputs, outputs, prerequisites, fine-tuning parameters, and potential challenges with solutions. Inputs. The prompt provided to the NVIDIA AI endpoint is a textual description of the desired image. For instance, a cat wearing a hat sitting on a beach would generate an image based on this description. Size refers to the dimensions of the generated image. The endpoint accepts parameters like width and height in pixels, enabling users to specify the image resolution. Outputs. The output of this component is the generated image itself, which is created based on the prompt and other parameters. Steps. The langchain component interacts with the NVIDIA AI endpoint by sending the provided prompt as a request. Upon receiving the request, the NVIDIA AI endpoint processes the prompt, generates the image based on its understanding, and sends the image back to the langchain component as a response. The component then returns this generated image as the output. Prerequisites. NVIDIA AI endpoint. This refers to a web service or application programming interface API provided by NVIDIA that exposes AI models like Stable Diffusion and DAL for image generation. To access this endpoint, you need a valid application programming interface API key in the endpoint's URL. NVIDIA AI model. NVIDIA offers various AI models specialized in image generation, such as Stable Diffusion and DAL. These models, trained on massive datasets of images and text, are capable of creating realistic and diverse imagery based on user prompts. Fine-tune parameters. Image size refers to the resolution of the generated image, allowing users to adjust the width and height of the output. Fine-tuning this parameter can affect the quality and detail of the generated image. Number of inference steps refers to the number of iterations or calculations that the AI model performs during the image generation process. A higher number of steps generally leads to more detailed and refined images, but may also increase processing time. Challenges and fixes. Endpoint not found or inaccessible. This indicates that the provided URL for the NVIDIA AI endpoint is incorrect or the endpoint itself is unavailable. To resolve this, double-check the endpoint URL for typos and ensure that the endpoint is online and reachable. Rate limiting or API key issues. The NVIDIA AI endpoint may impose rate limits on API calls to prevent abuse or resource depletion. Exceeding these limits can result in errors. Additionally, an invalid or expired application programming interface API key could prevent access. To address this, review your application programming interface API key and check your usage against any rate limits imposed by the NVIDIA AI endpoint. Model not available or unsupported. The specific NVIDIA AI model requested for image generation may be unavailable due to maintenance, temporary downtime, or because the endpoint doesn't support it. To fix this, verify that the requested model is available and supported by the NVIDIA AI endpoint. Consider using an alternative model or contacting NVIDIA support for assistance. Langchain NVIDIA AI Endpoints Image Gen Image Parser Summary. This section provides a comprehensive description of the langchain NVIDIA AI Endpoints Image Gen Image Parser component. It outlines how this component utilizes NVIDIA's AI endpoints for image parsing tasks. Inputs. Image. This refers to the input image that the component will process. It can be a variety of image formats, such as JPEG, PNG, or others supported by the NVIDIA AI endpoint. Image encoding. This input represents the encoded form of the image. Different encodings, e.g., base 64, might be required depending on the specific NVIDIA AI endpoint's requirements. Outputs. Text. This is the primary output of the component. It represents the extracted text from the input image. The output text may include the text content present in the image, such as text in diagrams, charts, or other visual representations. Steps. Uploads image to NVIDIA AI endpoint. The initial step involves uploading the input image to the specified NVIDIA AI endpoint. This upload process will typically involve transferring the image data to the endpoint's server for processing. Extracts text from image. Once the image is successfully uploaded, the NVIDIA AI endpoint processes the image using its image parsing capabilities. This process analyzes the image and attempts to identify and extract text content present within the image. Prerequisites. NVIDIA AI endpoint. This refers to the NVIDIA AI service that hosts the image parsing functionality. It's essential to have access to a suitable NVIDIA AI endpoint that supports image parsing capabilities. Image parsing API endpoint URL. This is the specific URL of the API endpoint within the NVIDIA AI service that handles image parsing requests. This URL is crucial for directing requests to the correct processing resource. API key. This represents the API key that authenticates access to the NVIDIA AI endpoint. API keys are used for security purposes to ensure only authorized users or applications can access the image parsing services. Fine-tune parameters. Model. This parameter allows users to select the specific image parsing model to be used for text extraction. Different models might offer varying levels of accuracy or performance depending on the complexity of the image and the type of text present. Confidence threshold. This parameter lets users set a threshold for the confidence level required for extracted text. The confidence level indicates the model's certainty about the correctness of the extracted text. A higher threshold implies only text with high confidence levels will be output. Challenges and fixes. API key authentication issue. This challenge refers to potential problems related to the authentication process when accessing the NVIDIA AI endpoint using the API key. Verify API key and endpoint URL. The recommended fix for authentication issues is to carefully verify the provided API key and the endpoint URL. Ensure both values are correct and match the configurations for the specific NVIDIA AI endpoint. Endpoint response parsing issues. This challenge describes difficulties that may arise when parsing the response provided by the NVIDIA AI endpoint after processing the image. Check endpoint documentation for response format to address response parsing issues. It's essential to consult the endpoint documentation to understand the expected format of the response. This documentation will provide details about the structure and content of the response, allowing you to parse it accurately. Langchain nvidia AI endpoints image gen nvidia summarization. A description of how to generate images using text prompts from nvidia's AI models. Inputs. Text prompt: a text input that describes the image that the user wants to generate. The prompt is used to guide the AI model in understanding what the user wants to be generated. For example, a user might input a cat sitting on a couch as a text prompt to generate an image of a cat sitting on a couch. Outputs. Image data. This is the output of the image generation process. The image data represents the generated image that is returned to the user. The image data can be represented in different formats like JPEG, PNG, etc. Steps. Submit a text prompt. The user sends the text prompt to the NVIDIA's AI model through the application programming interface API. Retrieve the image data after receiving the text prompt. The AI model processes the request and generates the image data. This generated image data is then retrieved through the API and returned to the user. Prerequisites. NVIDIA AI Endpoint Application Programming Interface API key. The API key is a unique identifier that authorizes access to the NVIDIA AI endpoint services. It is required for authentication and security purposes. The API key is usually a string of characters that is provided by NVIDIA after registering for their services. It is often used in combination with a secret key to authenticate requests to the API. An example of an API key could be your NVIDIA API key. NVIDIA AI Endpoint URL. This is the address of the NVIDIA AI Endpoint service. It is used to direct requests to the correct location. The URL typically includes the hostname and port number of the service. An example of an API endpoint URL might look like this: your NVIDIA API endpoint URL. Fine-tune parameters. Model name. The specific name of the NVIDIA AI model that the user wants to utilize for image generation. NVIDIA provides different models with varying capabilities. Image size. This parameter defines the desired resolution of the generated image. It is typically specified in pixels, such as 1024 by 1024 for a 1024 by 1024 pixel image. Image format. The format in which the generated image should be saved. Popular formats include JPEG, PNG, and BMP. Number of images. This parameter controls how many images are generated based on the user's input. Text prompt. Challenges and fixes. Application Programming Interface API key incorrect or missing. This error occurs when the API key used to access the NVIDIA AI endpoint services is invalid or absent. To fix this, the user should verify that the API key is entered correctly and that it is valid. The API key should be checked for any typos or inconsistencies. Application Programming Interface API endpoint URL is wrong. This occurs when the URL used to access the NVIDIA AI endpoint services is incorrect. The user should double-check that the API endpoint URL is entered accurately. Ensure that the hostname, port number, and path are all correct. Model is not available or unsupported. This error indicates that the specified model name is not recognized or supported by the NVIDIA AI endpoint services. The user should ensure that the chosen model name is valid and supported by the NVIDIA AI endpoint services. They can refer to the NVIDIA documentation to verify the available models. Error in image generation. This error signifies a problem in the image generation process, possibly due to an invalid text prompt, incorrect parameters, or model issues. The user should review the text prompt for any errors or ambiguity. They should also check the provided parameters, such as image size, format, and number of images, to ensure they are valid. Additionally, the chosen model should be evaluated for its suitability to generate the desired image. Image format is not supported. This error indicates that the specified image format is not recognized or supported by the NVIDIA AI endpoint services. The user should ensure that the chosen image format is supported by the NVIDIA AI endpoint services. Common formats include JPEG, PNG, and BMP. Number of images is invalid. This error occurs when the provided number of images is not valid or acceptable by the NVIDIA AI endpoint services. The user should ensure that the number of images requested is within the permissible limits set by the NVIDIA AI endpoint services. They can refer to the NVIDIA documentation for the allowed range of values. Langchain NVIDIA AI endpoints LLM summary. This describes a method for integrating large language models (LLMs) with the NVIDIA AI platform for efficient and cost-effective inference. NVIDIA AI endpoints provide optimized infrastructure for running LLMs, enabling developers to leverage their capabilities for various applications while minimizing resource consumption. By utilizing NVIDIA AI endpoints, users can gain access to high-performance computing resources, leading to faster execution speeds and reduced costs associated with LLM inference. Inputs. Text input provided to the LLM for processing. This could be a prompt, question, or any other form of textual input that the LLM is designed to handle. For example, a user could input "What is the capital of France?" to receive a response from the LLM. Outputs. The response generated by the LLM based on the input text. This output can take various forms, such as text, code, or even creative content, depending on the LLM's capabilities and the nature of the input. For example, in response to the prompt "What is the capital of France?" the LLM might output Paris. Steps. Establish a connection between LangChain and the NVIDIA AI endpoint. This involves setting up the necessary configuration details, such as endpoint URL, authentication credentials, and API keys. LangChain is a powerful framework that simplifies the interaction with LLMs and external services, like NVIDIA AI endpoints. This step ensures that LangChain can communicate with the NVIDIA AI platform for LLM inference. Choose and load the specific LLM model that will be used for inference. Many LLMs are available on the NVIDIA AI platform, each with its own strengths and weaknesses. For example, you might choose a model specifically designed for text generation, translation, or question answering. The appropriate model selection depends on the desired application and the characteristics of the input data. Send the text input to the loaded LLM through the established connection with the NVIDIA AI endpoint. This triggers the LLM's processing of the input, utilizing the NVIDIA AI endpoint's computing resources for efficient and rapid inference. Process the LLM's response for further use. This may involve formatting, extracting relevant information, or integrating the response into other systems. For example, if the LLM generated a list of relevant facts in response to a query, you might process this output to extract specific information or to summarize the key points. Prerequisites. An active account on the NVIDIA AI platform is required to access and utilize the NVIDIA AI endpoints. This account provides the necessary authorization and resources for configuring and using the platform. The NVIDIA AI platform is a cloud-based platform offered by NVIDIA for developing and deploying AI applications. Obtaining an account is typically straightforward and involves registering on the platform's website. The NVIDIA AI endpoint must be configured and ready for use before you can perform LLM inference. This configuration involves specifying details such as the desired LLM model, resource allocation, and connection settings. The NVIDIA AI endpoint acts as a bridge between the user application and the NVIDIA AI platform, allowing for seamless integration and execution of LLM inference tasks. Configuring the endpoint involves selecting the appropriate resources and settings based on specific LLM model and workload requirements. Fine-tune parameters. Choosing the most appropriate LLM model for the specific task is crucial for achieving optimal performance and results. Factors to consider include the model size, training data, and specialization. For instance, a large language model trained on a massive dataset of text might be suitable for general tasks, while a smaller model specialized in a specific domain might be more appropriate for tasks within that domain. Inference settings fine-tune the execution of LLM inference, affecting performance and cost. These settings include the batch size, which determines the number of input texts processed simultaneously, and concurrency, which defines the number of parallel inference requests. Optimizing these settings allows for balancing performance with resource utilization, leading to efficient and cost-effective inference. Challenges and fixes. Ensuring a reliable connection between the application and the NVIDIA AI endpoint is essential for uninterrupted LLM inference. This involves verifying the endpoint configuration, including the correct URL, credentials, and API keys. Issues can arise if there are mismatches or inconsistencies in the configuration details. Troubleshooting involves reviewing the configuration settings and confirming their accuracy, ensuring proper communication between the application and the endpoint. Latency in LLM inference can occur due to various factors, including the model's complexity, the workload, and the available resources. Optimization strategies involve choosing a model with a suitable balance of performance and resource requirements, adjusting the inference settings like batch size and concurrency, and ensuring adequate resources are allocated to the NVIDIA AI endpoint. This ensures that the inference process is completed within acceptable timeframes, meeting the performance expectations for the application. Minimizing costs associated with LLM inference is crucial for long-term sustainability. The NVIDIA AI platform offers different pricing models based on resource consumption and usage patterns. Exploring these models and adjusting resource scaling based on workload demands allows for cost optimization. This involves choosing the most cost-effective pricing model for the application's usage patterns, ensuring appropriate resource allocation to avoid unnecessary costs while maintaining sufficient performance. Langchain NVIDIA AI Endpoints LLM Summary. This description elaborates on the core functionality and purpose of the langchain NVIDIA AI Endpoints LLM. It's a large language model LLM designed to harness the power of NVIDIA's AI platform. This integration signifies a potent combination of advanced AI capabilities and optimized processing power for efficient language model execution. The LLM leverages NVIDIA's extensive infrastructure and resources to deliver powerful natural language processing capabilities. Inputs. This input represents the textual prompt provided by the user. It serves as the initial instruction or question that the LLM aims to interpret and respond to. The user can formulate their request in the form of a question, a statement, or a command, providing the LLM with the context for generating an appropriate response. For example, A user could input a prompt like write a poem about the beauty of nature, prompting the LLM to compose a poem based on the provided theme. This input represents contextual information relevant to the user's prompt. This supplementary information can further clarify the intent behind the prompt, providing the LLM with additional context to refine its response. For instance, a user could provide contextual information like I am interested in poems about the beauty of nature in the Appalachian Mountains, adding a geographical and thematic layer to the prompt, leading to a more focused and tailored poem. Outputs. This output represents the generated text produced by the LLM in response to the user's prompt. It can take various forms, such as a paragraph, a poem, a story, or a summarization of a given text. The LLM's output reflects its understanding of the prompt and its ability to generate coherent and relevant text based on the provided input. For example, in response to the prompt write a poem about the beauty of nature, the LLM might produce a poem like, the sunbeams dance upon the leaves, a gentle breeze whispers through the trees, a symphony of nature's song, a masterpiece, where beauty belongs. This output represents code generated by the LLM based on the user's prompt. The LLM can generate code in various programming languages, including Python, JavaScript, and C. It can translate natural language instructions into executable code, assisting developers with tasks like code completion, bug fixing, and writing new functions. For instance, a user could provide a prompt like write a Python function to calculate the factorial of a number, leading the LLM to generate the following Python code. Python def factorial if n0 return 1 else return n factorial 1. Steps. This step involves the user initiating the interaction with the LLM. They provide a text prompt and optionally supplement it with contextual information. This input sets the stage for the LLM's processing and response generation. This step encompasses the LLM's internal processing of the user's prompt and any accompanying contextual information. The LLM leverages its vast knowledge base and advanced language processing capabilities to comprehend the meaning and intent behind the user's input. This step marks the output generation stage, where the LLM produces its response based on the processed input. Depending on the prompt, the output can be generated text, code, or a combination of both. The LLM's output reflects its understanding of the input and its ability to communicate effectively with the user. Prerequisites. This prerequisite refers to an account on the nvidia AI platform. The nvidia AI platform provides the computational infrastructure and resources required to run the langchain nvidia AI endpoints LLM. This platform offers access to high-performance GPUs and optimized software environments, enabling efficient execution of the LLM. Users need to have an active account to access and utilize the platform's resources. NVIDIA AI Platform URL. This represents the official URL for the NVIDIA AI platform, where users can access their account and manage their resources. The URL provides a central access point for users to interact with the platform and leverage its capabilities. This prerequisite refers to the langchain library, a Python library that simplifies interaction with LLMs. The langchain library provides tools and utilities for managing prompts, handling input and output, and integrating LLMs into various applications. It facilitates a streamlined and efficient interaction with the LLM, simplifying the development and deployment of AI-powered applications. Langchain installation instructions. This represents the official documentation and instructions for Installing the langchain library. These instructions guide users through the process of setting up the library on their systems, ensuring compatibility and functionality. Fine-tune parameters. This parameter, known as temperature, influences the randomness and creativity of the LLM's generated text. A higher temperature value promotes more diverse and unpredictable outputs, while a lower temperature value produces more deterministic and predictable responses. The temperature value essentially governs the level of exploration and experimentation in the LLM's response generation process. This parameter, known as top K, controls the number of most probable words considered by the LLM during response generation. A higher top K value allows the LLM to explore a broader range of possibilities, potentially leading to more creative and diverse outputs. Conversely, a lower top K value restricts the LLM to a smaller set of words, producing more predictable and focused responses. This parameter, known as top P, governs the probability distribution of the words considered by the LLM during response generation. It limits the output to a subset of the most probable words, where the cumulative probability of the selected words reaches a specified threshold. A higher top P value allows for a wider range of words to be considered, potentially leading to more creative and diverse outputs. Conversely, a lower top P value restricts the LLM to a narrower set of words, producing more predictable and focused responses. Challenges and fixes. High latency can pose a challenge in real-time applications involving LLMs. This delay in response time can be attributed to various factors, including network congestion, processing power limitations, and the computational complexity of the LLM. To mitigate high latency, optimizing the network connection can significantly improve response times. This involves ensuring a stable and high bandwidth network connection, minimizing network hops, and potentially utilizing content delivery networks (CDNs) to geographically distribute content and reduce latency. Limited context window refers to the constraint on the amount of text the LLM can process and retain during a single interaction. This limitation can hinder the LLM's ability to comprehend and respond effectively to prompts that require a significant amount of context. To address this challenge, users can employ smaller prompts or utilize context chunking techniques. Chunking involves breaking down lengthy prompts or texts into smaller segments, allowing the LLM to process each segment individually and retain a more manageable amount of context. Model bias can occur in LLMs trained on datasets that are not representative of the real world or contain inherent biases. This can lead to biased outputs, reflecting the biases present in the training data. To mitigate model bias, using diverse training data and implementing bias mitigation techniques are crucial. Diverse training data ensures that the LLM is exposed to a wider range of perspectives and experiences, reducing the likelihood of biased outputs. Bias mitigation techniques involve identifying and addressing biases in the training data and in the LLM's output, promoting fairness and inclusivity in AI-generated responses. Limited code generation capabilities may arise in LLMs that have not been specifically trained on code data. This can result in suboptimal code generation, with potential errors or inefficiencies. To address this challenge, users can leverage specialized code generation LLMs or fine-tune the model with code data. Specialized code generation LLMs are designed specifically for code generation, offering improved accuracy and efficiency. Fine-tuning the model with code data involves providing the LLM with additional code examples during the training process. enabling it to learn and refine its code generation capabilities. Cost considerations are an important aspect of using LLMs. The computational resources required to run LLMs can incur significant costs. To optimize costs, users can focus on prompt lengths and leverage cost-effective NVIDIA AI instances. Minimizing prompt lengths reduces the computational workload, leading to lower costs. Leveraging cost-effective NVIDIA AI instances allows users to access the necessary processing power, while optimizing resource utilization and minimizing expenses. Langchain NVIDIA AI endpoints re-ranking NVIDIA re-rank. The component named langchain NVIDIA AI endpoints re-ranking NVIDIA re-rank leverages NVIDIA's re-ranking endpoint to enhance search results. The re-ranking endpoint is a powerful AI tool that can improve the quality of search results by reordering them based on their relevance to the query. This allows users to find the information they need more quickly and easily. Inputs: a user's search query or question. This is the information that the user is looking for. A list of initial results that have been retrieved from a search engine. This is a set of results that have been deemed potentially relevant to the user's query but may not be in the optimal order. Outputs: a list of re-ranked results. This is a list of the initial results that have been reordered by the re-ranking endpoint to better reflect their relevance to the user's query. Steps: the component submits the user's query and the initial results to the NVIDIA re-rank endpoint. The NVIDIA re-rank endpoint processes the query and results and returns a list of re-ranked results. Prerequisites: the NVIDIA Application Programming Interface key or API key is needed to access the NVIDIA re-ranking endpoint. This API key is required to authenticate the user with the NVIDIA service. It can be obtained from the NVIDIA Developer Portal by creating an account. The NVIDIA re-rank endpoint URL is needed to connect to the NVIDIA re-ranking endpoint and submit pay query and initial results. This URL can be found in the NVIDIA documentation for the re-ranking endpoint. Fine-tune parameters. The top K parameter controls the number of results that are returned from the re-ranking endpoint. A higher value for top K means that more results will be returned. The scoring function parameter specifies the algorithm used to re-rank the results. Different scoring functions can produce different rankings, depending on the desired criteria. Challenges and fixes. An API key authentication error might occur if the API key is invalid or the endpoint URL is incorrect. To fix this, it's crucial to verify the API key's validity and the accuracy of the endpoint URL. An invalid input format error occurs when the query or initial results do not meet the specifications required by the API. To resolve this, ensure the query and results comply with the API's format and structure. Rate limiting may occur when the user exceeds the maximum number of requests allowed within a specific time frame. Implement rate limiting strategies to avoid exceeding the allowed limits and ensure continuous access to the endpoint. For instance, the component can employ a token bucket algorithm to manage the rate of requests. Endpoint downtime occurs when the NVIDIA re-rank endpoint is unavailable. Implementing retry mechanisms allows the component to try again at a later time if the endpoint is temporarily unavailable. This can be achieved by using a back-off strategy, where the component waits for a certain duration before retrying. Latency issues can arise due to network congestion or inefficient query formulation. Optimizing query formulation and selecting an appropriate endpoint can help reduce latency. For example, using shorter and more specific queries can significantly improve response times. Performance tuning involves optimizing the performance of the re-ranking process. Adjusting the top K parameter, which defines the number of results returned, can influence the speed of the process. Additionally, experimenting with different scoring functions can improve the effectiveness of the re-ranking. Cost optimization aims to minimize the cost associated with using the nvidia re-rank endpoint. Utilizing cost-effective endpoint tiers can help manage costs without compromising the quality of the re-ranking process. For example, choosing a tier with a lower rate for requests can reduce overall costs. Langchain nvidia AI endpoints re-ranking ranking. This ranking method involves re-ranking results obtained from nvidia AI endpoints, which are specialized AI services. By leveraging langchain, a powerful framework for building and connecting language models. Inputs: a natural language query that represents the user's information need or request. A collection of documents retrieved based on the user's query. These documents could be from various sources and are initially ranked based on a retrieval system's relevance score. Outputs: a refined list of documents where the order of documents is adjusted based on their relevance to the user's query. This re-ranking process improves the quality of the retrieved results by taking into account the user's context and intent. Steps: first, documents are retrieved from nvidia AI endpoints. These endpoints are dedicated AI services that provide capabilities like text retrieval, document understanding, and other AI-powered functionalities. Next, langchain is used to re-rank the retrieved documents. Langchain provides a set of tools and functionalities for building and connecting language models. Its re-ranking capabilities allow for more sophisticated relevance assessment by considering the context of the query and the retrieved documents. Prerequisites: access to nvidia AI endpoints is required, which are AI services hosted by NVIDIA. These endpoints provide APIs for various AI tasks, including text retrieval and re-ranking. The retrieval API is used to retrieve documents from a specific knowledge base or dataset based on the provided query. This API leverages advanced algorithms to identify relevant documents that match the user's intent. The re-ranking API is used to further refine the ranking of the retrieved documents. This API typically employs advanced language models or ranking algorithms to assess the relevance of documents based on the query and the content of the retrieved documents. Langchain is a framework that simplifies the process of building and connecting language models. It provides pre-built components for tasks like retrieval, re-ranking, and document processing, making it easier to incorporate language models into applications. The langchain, chains, re-ranking, base re-ranker class provides a foundation for building custom re-ranking chains, enabling users to customize the ranking process based on specific needs or domain requirements. Fine-tune parameters. The parameters used to fine-tune the re-ranking model play a crucial role in the model's performance. These parameters may include factors like the model's architecture, training data, and learning rate. Fine-tuning these parameters allows the model to better understand the specific nuances of a target domain and improve its ability to rank documents accurately. The scoring function is essential in re-ranking and determines how the relevance of each document is calculated. Different scoring functions can be employed based on the nature of the data and the specific requirements of the task. For example, a scoring function might consider the similarity between the query and document content, the presence of key terms, or the document's overall quality. Challenges and fixes. NVIDIA AI endpoints are often designed for high-performance AI tasks. but they can sometimes experience latency, which is the time delay between submitting a request and receiving a response. Optimizing query formulation involves crafting queries that are precise and concise, eliminating unnecessary words or phrases that might slow down retrieval. This can be achieved by understanding the underlying retrieval system and using appropriate query keywords or phrases that are relevant to the specific information need. Re-ranking models often rely on complex algorithms and extensive training data, which can sometimes lead to performance issues. Fine-tuning the re-ranking model with domain-specific data involves training the model on a dataset that is relevant to the specific domain or industry. This specialized training can improve the model's ability to understand the nuances of the domain and make more accurate ranking decisions. Re-ranking results from nvidia AI endpoints using langchain. A description of the langchain nvidia AI endpoints tool. This tool enables langchain to interact with nvidia AI endpoints, providing access to a vast range of powerful AI models for tasks like natural language processing, image analysis, and more. Inputs. The name of the NVIDIA AI endpoint model to use. This name uniquely identifies the deployed model within the NVIDIA AI endpoint service. For example, you might use BERT-base encased for a pre-trained BERT language model or ResNet 50 for a convolutional neural network for image classification. The application programming interface API key associated with your NVIDIA AI endpoints account. This key is necessary for authentication when making requests to the service. It provides the tool with the authorization needed to access your deployed models. You can find your API key in the NVIDIA AI endpoints console. Outputs. The response returned from the NVIDIA AI endpoint after processing your request. This response will vary depending on the model you've chosen and the input you've provided. It could be a text string, a set of predictions, or any other format relevant to the model's capabilities. Steps. The langchain tool will first need to be initialized. This involves configuring the tool with the necessary information such as the API key and endpoint URL. During initialization, langchain establishes a connection to the NVIDIA AI endpoint service and prepares for interactions with the specified model. Once the tool is set up, langchain will send your request to the NVIDIA AI endpoint. This request will include the input data you've provided and any relevant parameters. The tool will then wait for the model to process the request and return its response. Prerequisites. An NVIDIA AI endpoints account is essential to use this tool. This account grants you access to the platform's services, including model deployment and management. You can sign up for a free trial to explore the platform and its capabilities. An NVIDIA AI endpoints application programming interface API key is required to authenticate your requests to the service. This key is unique to your account and provides access control to the deployed models. You can generate and manage API keys within the NVIDIA AI endpoints console. You need to have an NVIDIA AI endpoint model successfully deployed and ready for use. This involves choosing a model from the NVIDIA AI catalog or providing your custom model. The model must be deployed and configured to receive requests from external services like langchain. Fine-tune parameters. The URL of the NVIDIA AI endpoint where your deployed model is hosted. This URL provides the endpoint for langchain to send requests. You can find this URL in the NVIDIA AI endpoints console after deploying your model. It's a unique identifier for your specific model deployment. Headers are additional information sent along with the request to the NVIDIA AI endpoint. They can include details like authorization information, content type, or other metadata that the endpoint may need to process the request correctly. Challenges and fixes. Authentication errors can occur if your API key is invalid or if it doesn't have the necessary permissions to access the specified model. Check the API key you are using and ensure it's correct and has the necessary access permissions. Double-check the endpoint URL to make sure it's correctly pointing to your deployed model. Endpoint not found errors indicate that langchain cannot locate the nvidia AI endpoint you specified. This could be because the model hasn't been deployed correctly, or the endpoint URL is incorrect. Verify that the endpoint URL you are using matches the URL provided in the nvidia AI endpoints console after deploying your model. Check the status of your deployed model to make sure it's running and accepting requests. Langchain NVIDIA AI Endpoints Tool Summary. A YAML file describing the language chains NVIDIA AI Endpoints tools. These tools facilitate communication and interaction with NVIDIA AI endpoints. They enable users to leverage the power of NVIDIA's AI models and services within their applications. Inputs. The input text provided to the tool for processing. For example, a question to be answered by a language model or an image to be analyzed. The name of the specific AI model available on the NVIDIA AI endpoint that will be used for processing. This model name identifies the desired AI model for the task. Outputs. The response generated by the NVIDIA AI endpoint based on the provided input and the selected model. The output format will depend on the specific model and the task being performed. Steps. The tool is initialized by setting up the necessary connections and configurations for interacting with the NVIDIA AI endpoint. This involves establishing a communication channel and confirming that the required resources are available. A connection to the NVIDIA AI endpoint is established. This connection allows the tool to send requests and receive responses from the endpoint, effectively enabling communication with the AI models hosted there. The processed input text or data is sent to the endpoint along with the chosen model name. This initiates the inference process where the AI model processes the input to generate an output. The tool retrieves the generated response from the NVIDIA AI endpoint. This response contains the output of the AI model, representing the results of the inference process. Prerequisites. NVIDIA Triton Inference Server. This server is a high-performance inference platform that enables efficient deployment and execution of AI models. A minimum version of 21.08 or later is required to support the functionality of these tools. Version 21.08 or later. This specifies the minimum required version of the NVIDIA Triton Inference Server. Versions earlier than 21.08 may not provide the necessary features or compatibility for these tools. NVIDIA AI Endpoints SDK. The SDK provides tools and libraries necessary for interacting with NVIDIA AI endpoints. It facilitates communication and data exchange with the endpoints. Version 1.0 or later. This indicates that version 1.0 or later of the NVIDIA AI Endpoints SDK is required. Older versions might lack the necessary features or compatibility for these tools. Fine-tune parameters. Model name specifies the name of the specific AI model to be used for processing the input. This allows users to select the appropriate model for their task. Endpoint URL. The URL address of the NVIDIA AI endpoint where the AI models are hosted. This URL identifies the specific location of the endpoint where requests will be sent. API key and application programming interface. API key is used for authentication and authorization purposes when accessing the NVIDIA AI endpoint. This key ensures secure and controlled access to the resources available on the endpoint. Challenges and fixes. Connection issues. These issues arise when the tool cannot establish a connection to the NVIDIA AI endpoint. They could be caused by network connectivity problems, firewall restrictions, or other network-related problems. Check network connectivity. Ensure that the network is functioning properly and that there are no connectivity issues between the tool and the endpoint. This can involve checking network settings, verifying internet connection, and resolving any potential network failures. Authentication errors. Authentication errors occur when the tool fails to authenticate with the NVIDIA AI endpoint. This can be due to incorrect API key or endpoint URL, or expired credentials. Verify API key and endpoint URL. Double-check the validity of the API key and the accuracy of the endpoint URL. Ensure that the API key is correctly entered, that the endpoint URL is accessible, and that both are consistent with the configuration. Model not found. This issue arises when the requested AI model is not available on the NVIDIA AI endpoint. This can happen if the model name is incorrect, the model has been removed, or the endpoint configuration is outdated. Check model name and endpoint configuration. Verify the model name and confirm that it matches the name of an available model on the endpoint. Check the endpoint configuration to ensure that it lists the desired model. Inference errors. These errors occur during the inference process, where the AI model fails to process the input data correctly. This can be due to issues with the model itself, incorrect input format, or limitations in the model's capabilities. Review model input and output specifications. Carefully examine the input and output requirements for the chosen AI model. Ensure that the provided input adheres to the model's specifications and that the output format is appropriate for the intended use. Langchain NVIDIA AI Endpoints Tools. Server Tools Mixin. This tool provides functionalities for interacting with NVIDIA AI endpoints, which are powerful cloud-based services for running machine learning models. Inputs. Credentials necessary for authenticating with NVIDIA AI endpoints, typically involving an API key and endpoint URL. These credentials allow the tool to access and interact with the NVIDIA AI endpoint services. Requests to be sent to the NVIDIA AI endpoints. These requests specify the desired operations to be performed on the NVIDIA AI endpoints, such as model inference, training, or data management. The requests typically include the model name, input data, and any relevant parameters. Outputs. Responses received from the NVIDIA AI endpoints. These responses represent the results of the executed requests, such as predictions from a model, training progress updates, or data manipulation results. The responses are typically formatted as JSON or other structured data formats. Steps. Establish a connection to the NVIDIA AI endpoints using the provided credentials. This involves verifying the credentials and obtaining an authorized session with the NVIDIA AI endpoint services. Send the prepared requests to the NVIDIA AI endpoints. This involves transmitting the requests through the established connection and waiting for the responses. Prerequisites. An API key is required for authentication with NVIDIA AI endpoints. This key is a unique identifier that grants access to the service and ensures that only authorized users can interact with the NVIDIA AI endpoints. You can obtain an API key from the NVIDIA AI endpoints platform. This API key is a sensitive credential and should be kept confidential. To prevent unauthorized access, you can obtain it from the NVIDIA AI endpoints platform after registering an account and creating an application. It might look something like your API key here. An endpoint URL is required to specify the specific NVIDIA AI endpoint service to interact with. This URL serves as the gateway to the desired NVIDIA AI endpoint service, allowing the tool to target specific functionalities. You can find the endpoint URL on the NVIDIA AI endpoints platform. The endpoint URL typically includes the hostname and port of the NVIDIA AI endpoint server. It might look something like HTTPS API, NVIDIA, COMI. Fine-tune parameters. The request timeout defines the maximum amount of time the tool will wait for a response from the NVIDIA AI endpoints before considering the request unsuccessful. This is useful to prevent the tool from hanging indefinitely if the NVIDIA AI endpoint server is unavailable or the request takes too long to process. The maximum number of retries specifies how many times the tool will attempt to resend a request if an error occurs. This allows the tool to handle transient network issues or temporary server outages by retrying the request until it is successful. Challenges and fixes. Connection errors occur when the tool cannot establish a connection with the NVIDIA AI endpoints server. This can be due to network connectivity issues, incorrect credentials, or the NVIDIA AI endpoint server being unavailable. To fix connection errors, first ensure that you have a stable internet connection. Then, carefully verify that your NVIDIA AI endpoint's credentials, including the API key and endpoint URL, are correct and valid. Finally, make sure that the NVIDIA AI endpoints server is reachable and online. Request errors occur when the tool successfully connects to the NVIDIA AI endpoint server but encounters problems during the request processing. This can be caused by invalid request formats, exceeding API limits, or issues with the NVIDIA AI endpoint server itself. To resolve request errors, first review the request format and ensure that it complies with the NVIDIA AI endpoint's API specifications. Check the API documentation and usage guidelines to confirm the expected request structure and parameters. Additionally, verify that your request does not exceed the API limits, such as the maximum number of requests per second or the size of the input data. Finally, if the issue persists, it might be necessary to investigate the NVIDIA AI endpoint server logs for errors or anomalies. Langchain NVIDIA AI endpoints tool summarization. This YAML document outlines a comprehensive approach for leveraging NVIDIA's AI model endpoints to perform various natural language processing tasks using langchain. It provides a structured framework for integrating NVIDIA's powerful AI models into custom workflows. Inputs. Text that will be processed by the AI model endpoint, serving as the raw input for the chosen model. This could be a paragraph, article, or any other textual content. Detailed configuration for the selected NVIDIA AI model endpoint, including specific settings like the model's name, version, and desired input-output formats. This ensures accurate interaction with the endpoint. Outputs. The result of processing the input text using the NVIDIA AI model endpoint. This can be various outputs depending on the chosen model, such as a summary of the input, a translation, or a classification. Steps. Initialize and configure the necessary langchain tools required for interacting with the NVIDIA AI model endpoint. This might involve creating tools for handling input formatting, authentication, and data transfer. Define and specify the exact configuration for the chosen NVIDIA AI model endpoint. This includes parameters like the model's name, version, region, and any special settings required for optimal performance. Employ the langchain tools to interact with the defined NVIDIA AI model endpoint. This involves sending the prepared input text to the endpoint, processing the response, and extracting the desired output. Prerequisites: an active NVIDIA AI platform account, which provides access to NVIDIA's extensive collection of pre-trained AI models. This account also enables users to manage and deploy their own custom models. An NVIDIA Application Programming Interface API key, which is essential for authenticating and accessing the NVIDIA AI platform. This key serves as a unique identifier and grants access permissions. The langchain library installed within a compatible Python environment. Langchain is a powerful Python library that facilitates building complex workflows involving interacting with various AI models and APIs. This installation ensures the availability of langchain's functionalities. A Python environment properly configured to run langchain. This includes having Python installed with the necessary libraries and dependencies. Fine-tune parameters. Specific settings for the selected NVIDIA AI model, such as the number of layers, activation functions, and optimization parameters. These parameters can be customized to fine-tune the model's performance for specific tasks or datasets. Configuration settings for the inference process, such as batch size, inference mode, and resource allocation. These settings impact the model's performance during inference, optimizing for factors like speed and accuracy. Challenges and fixes. Issues accessing the NVIDIA AI model endpoint, which can occur due to incorrect API key information, network connectivity problems, or misconfigured platform settings. Carefully verify the accuracy of the NVIDIA API key, ensuring it's correctly entered and authorized for access. Also, confirm that the platform configurations are aligned with the intended endpoint access permissions. Incompatibility between the format of the input text and the requirements of the chosen NVIDIA AI model endpoint. This mismatch can lead to errors during processing. Adjust the structure of the input data to precisely match the format expected by the chosen endpoint. This could involve restructuring the text, using specific data encodings, or employing specialized formatting tools. Langchain NVIDIA TRT LLM's Triton Tensor RT error. Error during Tensor RT inference. This error usually occurs when there is a problem with the Tensor RT inference process, which is a specialized deep learning inference engine for NVIDIA GPUs. It could happen due to various reasons such as memory allocation issues, incorrect model configuration, or incompatible tensor types. Inputs. Input tensor. The input tensor represents the data that will be fed into the Tensor RT model for inference. It typically contains the features or values that the model will use to make predictions. The input tensor is usually shaped as a multi-dimensional array, with each dimension corresponding to a specific aspect of the data. For example, in a natural language processing task, the input tensor might represent a sentence as a sequence of words, and each dimension could correspond to the word index, word embedding, or other relevant features. Model configuration. Model configuration encompasses the settings and parameters that define the structure and behavior of the Tensor RT model. It includes information such as the model architecture, the type of layers used, and the weights and biases learned during training. The model configuration is crucial for defining how the model will process the input data and generate output predictions. For example, a model configuration for a language model might specify the number of layers, the size of the hidden state, and the vocabulary used for encoding words. Outputs. Inference result. The inference result represents the output generated by the tensor-RT model after processing pay. Input tensor. This output can take various forms, depending on the task and model architecture. For example, in a classification task, the inference result might be a probability distribution over different classes, indicating the likelihood that the input belongs to each class. In a language generation task, the inference result could be a sequence of words or tokens that represent the generated text. Steps. Load model. Loading the model refers to the process of retrieving and initializing the tensor-RT model from a storage location, such as a file or a memory buffer. This step is crucial for making the model ready for inference. It typically involves reading the model configuration and weights from the storage and creating necessary data structures and objects in memory to represent the model. Execute inference. Executing inference involves applying the loaded tensor-RT model to the input tensor and generating the corresponding output. This step entails feeding the input tensor through the model's layers, performing the necessary computations, and producing the final prediction or result. The execution of inference typically involves optimized algorithms and techniques tailored for nvidia GPUs to accelerate the inference process. Prerequisites. nvidia GPU. nvidia GPUs are specialized graphics processing units designed for high-performance computing and parallel processing. They offer significant speed advantages in deep learning applications, including inference tasks. TensorRT leverages the parallel processing capabilities of NVIDIA GPUs to accelerate the inference process. Some popular NVIDIA GPU models that are often used for TensorRT inference include the RTX 3090 and the A100. RTX 3090. The RTX 3090 is a high-end NVIDIA GPU that offers powerful performance for demanding applications, such as deep learning inference. It features a large amount of memory, high clock speeds, and advanced features like ray tracing, making it suitable for handling complex models and large datasets. A100. The A100 is a high-performance NVIDIA GPU designed for data centers and large-scale deployments. It offers exceptional processing power and memory bandwidth, making it well-suited for intensive workloads such as deep learning inference. The A100's architecture and features cater to the needs of applications requiring high throughput and low latency. Triton Inference Server. Triton Inference Server is a powerful tool for deploying and managing deep learning models at scale. It provides a framework for serving models over a network and allows for efficient resource management and workload optimization. Triton Inference Server supports various deep learning frameworks, including TensorRT, and allows for seamless integration with different environments and applications. 22.08. 22.08 is a specific version of the Triton Inference Server. Each version of Triton Inference Server typically comes with new features, improvements, and bug fixes. 23.02. 23.02 is a specific version of the Triton Inference Server. Each version of Triton Inference Server typically comes with new features, improvements, and bug fixes. Fine-tune parameters. Batch size. The batch size represents the number of input samples that are processed simultaneously during inference. Choosing an appropriate batch size is essential for balancing efficiency and memory usage. A larger batch size can improve performance by leveraging parallel processing on the GPU. But it also requires more memory. A smaller batch size can reduce memory requirements but may slow down inference. Precision. Precision refers to the level of detail and accuracy used for representing numerical values during inference. Different precision levels, such as FP32 single precision floating point or a 16 half precision floating point, have different computational and memory requirements. Choosing the right precision level involves a trade-off between performance and accuracy, where higher precision generally leads to more accurate results but may require more resources. Challenges and fixes. Tensor shape mismatch. A tensor shape mismatch occurs when the shape of the input tensor does not match the expected shape of the tensor RT model. This can happen due to incorrect data preprocessing, inconsistencies in the model definition, or misaligned dimensions. To fix this issue, it is necessary to adjust the input and output shapes to ensure consistency with the models. Requirements. Adjust input and output shape. Adjusting the input and output shapes involves modifying the data processing steps to ensure that the input tensor is reshaped to match the model's expectations. This can involve resizing, padding, or other transformations depending on the specific requirement. Similarly, the output shape might need to be adjusted to align with the desired output format. Memory allocation failure. A memory allocation failure occurs when the tensor RT inference process runs out of available memory on the GPU. This can happen when the model is too large, the batch size is too high, or there are other processes consuming significant memory resources. To address this issue, one approach is to reduce the batch size, which lowers the memory footprint of the inference process. Reduce batch size. Reducing the batch size involves processing fewer input samples concurrently during inference. This can help to alleviate memory pressure and reduce the risk of allocation failures. The optimal batch size will depend on the available memory resources and the specific models. Requirements. Triton server unavailable. A Triton server unavailable error indicates that the Triton inference server is not accessible or operational. This could occur due to server downtime, network connectivity issues, or incorrect server configuration. To resolve this issue, it is necessary to start the Triton server and ensure that it is properly configured and accessible. Start Triton server. Starting the Triton server involves initiating the server process and ensuring that it is listening on the designated network port. This allows clients and applications to connect to the server and request inferences. Model loading error. A model loading error occurs when the tensor RT inference process encounters an issue while loading the model from storage. This can be caused by a variety of factors, such as an incorrect model path, corrupted model files, or permissions issues. To fix this issue, it is essential to check the model path and ensure that it is valid and points to the correct location. Check model path. Checking the model path involves verifying that the specified location in the configuration is accurate and that the model files are present at that location. This might involve reviewing the configuration settings, checking the file system, or confirming the existence of the model files. Invalid tensor type. An invalid tensor type error arises when the data type of the input tensor does not match the data type expected by the tensor RT model. This can happen due to incompatible data encoding, incorrect data conversion, or mismatched type declarations. To resolve this issue, it is necessary to convert the input tensor to the correct data type. Convert input tensor. Converting the input tensor involves transforming the data from its original data type to the expected data type of the tensor RT model. This may involve using data type conversion functions or libraries that are compatible with the specific deep learning framework being used. Summary of langchain nvidia TRT-LLMs Triton Tensor RT-LLM. A langchain wrapper for nvidia Triton inference server using Tensor RT to run large language models. This wrapper enables users to leverage the high performance and scalability of Triton inference server to run their large language models efficiently. Inputs: text input provided to the language model, serving as the input prompt for generating a response. For example, a user might provide the prompt "What is the capital of France?" The name of the language model being used. This could be a pre-trained model like GPT 3.5 Turbo or a custom model trained for a specific task. For example, the user could specify "My sentiment model" for a model trained to analyze sentiment in text. Outputs: the generated response from the language model in text format. The response is derived from the provided input prompt and the underlying model's capabilities. For example, the response to the prompt "What is the capital of France?" might be Paris. Steps: the langchain wrapper starts by initializing a client for the nvidia Triton inference server. This client facilitates communication between langchain and the Triton server. The wrapper prepares the input data according to the specific requirements of the language model, such as formatting the text prompt correctly. Then it sends this prepared data to the Triton inference server for processing. The wrapper retrieves the output data from the Triton server, which typically contains the generated text response. It parses the output data, ensuring it is in a readable format, and returns it to the user. Prerequisites: nvidia Triton inference server, a high-performance inference server for deploying AI models, must be installed on the system. The installation instructions and documentation for nvidia Triton inference server are available at https://github.com Triton inference server. Tensor RT, an NVIDIA library for optimizing deep learning models for inference, must be installed and configured to work with Triton inference server. Detailed guidance on installing and configuring Tensor RT can be found at https://developer nvidia.com Tensored. Fine-tune parameters: the name of the language model being used for inference. This is essential for correctly identifying and loading the desired model. For example, GPT 3.5 Turbo or My Sentiment model could be specified. The version of the language model. This can be useful for selecting a specific model version, especially if multiple versions are available. For example, 1.0 or 2.0 could be specified. The URL of the Triton inference server. This is required for the wrapper to connect to the server and send inference requests. For example, HTTP localhost 8000 could be used for a locally hosted server. The name of the input tensor for the language model. This parameter helps the wrapper correctly identify the input data provided to the model. For example, text input or prompt could be specified. The name of the output tensor for the language model. This is used to identify the output data generated by the model, allowing the wrapper to retrieve the correct result. For example, text output or response could be specified. Challenges and fixes: incorrect model configuration. If the configuration provided to the wrapper does not match the actual definition of the language model, inference might fail. To resolve this, carefully review the model definition and ensure the configuration settings such as model name, version, input and output names are correct. Performance issues: sometimes the performance of inference might not meet expectations. To address performance issues, optimize the model itself, including model architecture and parameters, as well as the server settings. This might involve tweaking batch sizes, adjusting the number of worker threads, or using hardware acceleration. Missing dependencies. The wrapper may encounter errors if necessary dependencies, such as specific libraries or Python packages, are not installed. Install any missing dependencies according to the wrapper's requirements and the specific language model being used. This can typically be accomplished using package managers like pip. Incorrect input or output data format. If the data provided to the model does not match the expected format, errors can occur during inference. Adjust the data format of the input and output according to the model's requirements, ensuring they are compatible with the specific tensor types and shapes expected by the model. This might involve adjusting the text encoding or the way data is structured in the tensors. Langchain nvidia TRT LLM's Triton Tensor RT runtime error. This document describes a runtime error that occurs while using langchain with nvidia TRT LLMs, specifically when interacting with the Triton Tensor RT runtime. This error indicates a problem during the execution of the Tensor RT engine, which is a high-performance inference engine for deep learning models. Inputs. The input text provided to the langchain model. This input could be a user query, a piece of text for analysis, or any data that the model is intended to process. Model configuration parameters, which define the settings for the Tensor RT engine. This includes specifications like the Tensor RT engine itself, its precision level, batch size, and other optimization parameters. Outputs. Generated output from the langchain model. This output could be a response to a user query, a summary of the input text, or any other results produced by the model. Error messages and stack traces. These outputs provide detailed information about the specific error that occurred during a runtime execution of the Tensor RT engine. They can include details about the location of the error, the type of error, and the conditions that led to the error. Steps. The input text is first processed by langchain, a framework that provides tools for building and deploying language models. Langchain handles tasks like tokenization, encoding, and preparing the input for the Tensor RT engine. Langchain then calls the Triton Tensor RT runtime, which is a software library responsible for running the Tensor RT engine. This runtime manages the execution of the engine and interacts with the underlying hardware. Resources. The Tensor RT engine attempts to process the input using its optimized inference engine. This involves performing calculations, applying neural network weights, and generating the desired output. The runtime error is thrown if an issue occurs during the execution of the Tensor RT engine. This could be due to various reasons, such as invalid input data, incorrect configuration, or resource limitations. Prerequisites. NVIDIA GPU with CUDA support. This refers to a graphics processing unit GPU from NVIDIA that supports the Compute Unified Device architecture. CUDA technology. CUDA allows the GPU to perform parallel computations, which is essential for efficient deep learning inference. NVIDIA drivers and CUDA toolkit installed. The NVIDIA drivers provide the software interface for the GPU, while the CUDA toolkit offers the necessary tools and libraries for developing and running CUDA applications, including the Tensor RT engine. Tensor RT installed and configured. Tensor RT is a library provided by NVIDIA that optimizes deep learning models for inference on NVIDIA GPUs. It converts models into a highly optimized format, reducing the inference time and improving performance. Tensor RT engine properly built and deployed. The Tensor RT engine is a specialized executable file that contains the optimized model for inference. It must be built from the original model using the TensorRT tools and deployed in a suitable environment, such as the Triton Inference Server. Fine-tune parameters, model architecture and hyperparameters. These parameters define the structure and internal workings of the deep learning model used for inference. They can include details like the number of layers, the type of neurons, and the activation functions. TensorRT engine settings such as precision and batch size. These settings determine how the TensorRT engine optimizes the model for inference. Precision defines the level of accuracy used in calculations, while batch size specifies the number of inputs processed simultaneously. Challenges and fixes. Invalid input data format. This error occurs when the input text provided to the langchain model does not conform to the expected format required by the TensorRT engine. Ensure input data type and dimensions match model requirements. The model expects specific data types, such as text strings, and specific dimensions, such as the length of the input text. Verifying that the input data matches these requirements is essential for successful processing. TensorRT engine configuration issues. These errors arise when the settings configured for the TensorRT engine do not match the model or the hardware resources available. Validate engine settings, input-output binding, and memory allocation. Carefully review the TensorRT engine configuration, including parameters like precision, batch size, and the mapping of input and output data. Also, ensure that the available GPU memory is sufficient for the engine's operation. Runtime memory exhaustion. This error happens when the TensorRT engine requires more memory than available on the GPU during execution. Increase GPU memory or reduce batch size. Consider increasing the amount of GPU memory available or reducing the batch size of the model, which will decrease the memory demands on the GPU. Unsupported operation or function. Some operations or functions used in the deep learning model might not be supported by the TensorRT engine. Check TensorRT compatibility in model operations. Ensure that the model uses operations and functions that are compatible with the TensorRT engine. Review the TensorRT documentation for supported operations and functions. Incorrect deployment or version mismatch. The TensorRT engine and the Triton server need to be deployed correctly and their versions must be compatible. Verify Triton deployment and ensure version compatibility. Ensure that the Triton server is correctly installed and configured, and that the TensorRT engine is properly deployed within the server's environment. Also, confirm that the versions of the Triton server and the TensorRT engine are compatible.